All right, production. So now we're going to continue with problem 14 with our quality control problem. And we got to answer what is the power to test. Then they are currently testing 5 items per hour. Someone has proposed they test 10 instead. What are the advantages and disadvantages of such change? And then what happens if they change the level of significance? And then what happens if the machine becomes more and more out of compliance? What does that mean as far as the power? Okay, so let's take a look at this. I'm going to copy down our null and alternative hypothesis. Okay, remember the null hypothesis that we said, okay, P equals 0.1, the assembly process is working fine. Okay, the alternative is it's producing too many defective items, and the assembly process is producing too many defective items. Okay. Let me zoom that out a little bit for you. Okay. Alright. So what is power? Well, the definition of power is correctly rejecting H sub O when H sub A is true. What does that mean? It means we correctly reject the null when the alternative is true. So what does that mean in context in this problem? It means, and that should be the probability of. The probability of. Okay? So in context, in this problem, it's the probability of correctly determining that the machine is producing too many defective items. Okay? When we're dealing with power, the alternative hypothesis is true. So this is true. It's the probability of correctly determining that. Okay? Now, we have 4 things that affect power. Okay? Sample size, alpha, effect size, and variation. Okay? So, when sample size goes up, power goes up. More evidence to convict the guilty defendant. When alpha goes up, power goes up. Okay? Larger alpha, less proof. Effect size, the more guilty it is, the more power. And then when variation increases, power decreases. And that's because these two are linked together. When sample size increases, variation goes down. Okay, well, if sample size has a direct relation to power, and sample size has an inverse relation to variation, then variation and power must have an inverse relationship as well. Okay? So, let's take a look at this problem. We already answered question A. Okay, so question B, what happens when they increase sample size from 5 to 10? Okay. Well, if we're talking about power, and power means that the alternative hypothesis is true, and the power is the probability of correctly determining this, then that means we have more evidence to make that determination, and that would be a good thing. Okay? So What is that good? Well, it's good if the machine is out of compliance. Okay, so there would be more power. Okay, so that's the advantage. Well, what's the disadvantage? Okay, you would have more cost spent to do that, and you would have more time spent doing the test. Okay, which isn't a bad thing. Again, we're talking about a machine that's out of compliance. And then C says they currently use a 5% level of significance. What are the advantages and disadvantages of changing to an alpha level of 1%? Okay, well, we think that P is 0.1. So this is what we call our hypothesized distribution. But let's say that the machine, I'm just going to make up a number. I'm going to say this is 0.2. Okay. So this is the actual distribution. So we're going to reject anything that has an alpha level, anything over here. Well, the true probability of us getting anything over here is this region right here, because this is the actual distribution. Okay. Well, we decide to change our alpha level. We're going to change our alpha level from 0.05 to 0.01. So that's this. And we're going to reject anything to the right of that. Okay? So anything in this region over here. What's the probability going to be of getting that? It's going to be this right here. So when we decrease the alpha level, we decrease the shaded region from this to this. So when alpha level went down, power went down. I always explain it the other way. I always say when alpha level increases, power increases, because you have a higher probability. Again, we're going to reject anything in this region because our actual region is over here. Okay, so higher alpha, more power. Okay? And then the last question is suppose that as the day passes, one of the machines on the assembly line produces more and more parts that are defective. All right. Well, let's say that the machine goes, it was in tune, now it's out of tune, and then we go even further. We're going to go and do something like this. Okay, so the machine's really out of whack now. Okay, so I'm just going to extend this down. Okay, actually I'm going to extend this down. So we're going to use alpha of 0.05. Okay, so let's say that portion of the items that are really out of whack is like now 0.3. Okay, well, the power of this test when the machine was starting to get out of compliance was this shaded region. Well, what percent of that distribution is shaded? Well, I'm going to say, I don't know, 65%. So the power of this was 65%. Okay, but now this much is shaded. I'm going to say, I don't know what's over there, 2.5%. So I'm going to say, I don't know, 92.5%. Well, what's this an example of? This is an example of the defendant that's more and more guilty. Okay, what defendant's easier to convict? This defendant or this defendant? Well, this defendant is, because this defendant is much more guilty. The more the machine is out of compliance, the easier it is to reject the null that the machine is in compliance and accept the alternative, the machine is out of compliance and needs to be shut down. Okay, so the farther out of compliance it goes, the more power that the test will have. Okay.